And that's a valid question. Going to try and explain that. We'll see how clear it ends up being. I would kind of liken it to functions and function pointers in C. So if you think about that a little bit, a function in C is basically, it's the actual code that's going to execute, right? You define a function, you write some code in there, that's the function, it's the thing that's going to execute. But you can reference that from somewhere else in your code by getting a pointer to it. So you get a pointer to the function, and that's a function pointer. It's not the actual function itself, it's a pointer to it, but it lets you call the function. So this is pretty similar. The method is, it's the code that you wrote, it's the method that you wrote in your class file, and it's the thing that's going to execute. The selector is a way to reference that. Now, because Objective-C is so dynamic, it doesn't actually reference the specific implementation of that method. It references any method that has that same name. But it's basically, that's the best analogy I can get with C. Does that make sense? Anyone unclear on that? Need a little more clarification? All right, excellent. Yeah, the method is the code that's selected by a message. There is one extension to all of that we haven't quite covered, but I mentioned briefly, which is the dot syntax. This is actually the properties that I talked about a little bit earlier. It's sort of directly related to that. So if you want to get to a particular instance variable on a class, or sorry, on an instance, you'll usually send a message to the class that has the same name as the instance variable or something related. And that would normally look like square brackets, person, and then height to get the height of the person. In Objective-C 2.0, you can also write that as person.height. It is actually identical. It does the exact same thing. It still goes through the normal message dispatch. It's just as dynamic as if you had written the other thing. Literally identical, just different syntax. So if you're kind of a person that likes to write little dots instead of square brackets, go for it. The same thing works for assignment. If you had a setHeight method and you were trying to pass in a height there, you could instead just write instance.height equals new height. And that will, the compiler will turn that into a call to the setHeight method. Yeah, so as it says at the bottom there, person child setHeight is the same as person.child.height equals new height. It's just another way of writing out the same thing.
What if we have more than one argument?
I'm sorry?
What if we have more than one argument?
So the question is, what if you have more than one argument? And the answer is, you cannot do that. These are really, they're really designed for property access, which would be getting and setting values. And when you're getting and setting a value, you're generally not passing in multiple arguments. You're just passing the one value. So it's really intended for that. It's just a single argument. Yeah.
Last slide. Were you saying that the equal sign will assign the opposite direction than it usually does, or what?
No, it assigns the normal direction. So person.height equals new height will set the height instance. Well, it'll call setHeight with the new height value as the argument. So assignment works in the same order that it would if you were just assigning to a value on a variable on the stack or something. All right, so we talked about a couple of new types in Objective-C already. Let's look at them a little bit more closely now. The dynamically typed objects. We've got the ID. That's we talked about it. I don't think we really saw it yet. That's the AnyObject type, basically. You can send any message to that the compiler knows about, and it's not going to complain. It'll crash when you're running it if the object that you're actually trying to send that message to doesn't respond to that particular method or implement that method. It's also important to note that you usually are going to want to deal with these just as ID, not as ID star. Most of the time when you're writing, when you're creating a variable in the stack for a particular class, like if you had a string variable, you'd write NSString star and then the variable name because it's actually a pointer to an NSString. An ID is implicitly a pointer, so it doesn't actually need the star. If you put the star there, it's actually going to end up being a pointer to a pointer. So yeah, you probably don't want the star unless you really, really mean that. Then there's also statically typed. I don't actually know what that was in reference to. Statically typed object.
Statically typed object.
Yeah, I'm not sure what that was in reference to.
Just the difference between ID, which is
Oh, right. So yeah, then the second line there is an explicitly typed object there. It's explicitly typing it as a person. object. So if you send a message to an object, the compiler knows that that thing is supposed to be a person object, and it'll complain if you try and send it a message that the person class doesn't implement. So yeah, Objective-C provides compile time, not runtime type checking. At runtime, it's not going to verify that the message that you're trying to send is going to the object that you thought it was going to at compile time. There's really no verification at runtime. The only verification is if the object that you're sending a message to doesn't implement that method, well, then it's going to crash. All of the type checking is done at compile time. And yeah, Objective-C, as we mentioned earlier, always uses dynamic binding. There's no compile time binding of this message send goes to exactly this method implementation. That's all lazy. The other thing that's been introduced with Objective-C, that's a new type, is the null object. It's nil. It's basically always just 0 typed to as an ID. You can compare it against an object to see if that object is valid, assuming you've initialized the object to nil. You can just implicitly not person. It'll do Boolean logic on it, and it'll just basically validate whether it's 0 or not. You can use it in assignments as an argument. Sometimes the place that you're actually passing it to, many places will accept nil as a valid argument. It kind of depends on the particular message that you're sending, and obviously for your own methods you can decide whether or not nil is a valid argument to your method. Yeah?
Is nil actually 0, or what is its actual definition?
So the question is nil actually 0? Yeah, nil is actually 0. It's literally checking to see is the value here 0. Yeah.
So how is that different than null?
The question is, how's that different than null? It's semantic, really. It's all, in that sense, null is also not necessary, right? Null is also just 0. I mean, you can just use a 0. It's for programmer happiness, I guess. Make yourselves feel good about using the right value. So you can also message nil. This is, in most other languages, this would immediately result in a crash and all sorts of bad things. In Objective-C, you can message nil. So if you have an object, or you have a pointer to an object, rather, before you send it a message, you don't necessarily have to check that the thing is non-null. You can just have null and call cast ballot on it, and nothing will happen. It'll be fine. If the method you were sending returned a value, in almost every case, that's totally cool. The value that you're guaranteed to get back there is always 0. So you can actually nest these things, which is one of the places this becomes really cool. If you've got a big nested expression, in other languages you might have to do just the first part of that expression and then immediately follow it with an if not 0 check before you did the rest. Here you can just nest that all on one line. You don't have to bother checking because you know that you can, even if the result of the first message is null, it's totally safe to call the rest because they're just going to be no ops. But yeah, so if you message null, the return value is always 0 unless the return value is a struct type. If the message returns a struct, then the contents of that result when messaging null are undefined. We get lots of good bugs with that one. A common place to see that is when you're dealing with setting frames of views and stuff on screen. You might try and convert a point or something from one, or convert a rect from one view to another, and then set that as the frame of another view. But if you didn't check to see if the thing you were doing if you didn't check to see if the instance you were doing the conversion of the rect with was non-null, and then relied on the result of that message, and that thing actually happened to be null, the rect that you get back is not guaranteed to be 0, 0, 0, 0. It's just whatever happens to be on the stack. So you can get some fun bugs with that. So yeah, if you're getting struct results back from messages, be careful, but otherwise, totally safe to message null. So when Objective-C was introduced, C did not actually have a Boolean type as part of the language. So we have a separate Boolean type defined in Objective-C. It's capital Bool. And we've got some separate constants to define 1 and 0 for that. It's obviously capital yes and capital no. We also define capital true and capital false, but yes and no are pretty commonly used. I could go either way with those, really, but and you can also just set 1 and 0 directly. The Boolean type for Objective-C is expected to be always 1 or 0. Yes and no, and true and false are always 1 and 0. Of course, if you're doing implicit checking, it doesn't really matter that it's exactly 1. As long as it's non-zero, it's true. Yeah, so those are the macros that are